Alright guys, this is my third take on this video. Hope it works out this time. There's been an interruption the past 2 times. We'll see how it goes. So this video we're going to learn how to do the diamond method, or the X factor, how to factor quadratics basically, and the way we're going to do it in class. So it's called the diamond method. Some of us call it the big X because we just draw the inner portion right there. But it's actually a diamond. I include this picture just so you can see what I mean by the diamond. So it actually takes this shape of a diamond, but we're not going to actually draw that, because think about that. That's going to be, I always mess it up. I can't even draw that. So what is it even about? It's just a factoring method. So let's go through this in a little bit of reverse. So x times x is x squared. X times b is bx. A times x is ax. And a times b is a times b. We don't really know what those are, so we'll leave it like that. So if we combine like terms, if you see right here, bx plus ax, I'm going to just factor out an x from those two, and it leaves us with b plus a. And I really want us to focus on something here. Basically, what multiplies to this number, there's two numbers that we got to think of. And remember our standard form of quadratics, ax squared plus bx plus c. So we're looking for two numbers that multiply. Two numbers multiply to this number and add to this. Don't get these b's mixed up. This is just the typical standard form of quadratics. So we're looking at two numbers that multiply to this number and add to be this number. So that's the reason why we use that diamond method. It's just an organizational method to help us out with that. So looking at this as an example, I'm going to put negative 10 on the top, negative 3 on the bottom. I always put c on the top. Some teachers put c on the bottom, b on the top. So just so you know, in my class, c is always on the top. So what multiplies the top number adds to the bottom? So negative 5 and positive 2. And if you don't know, if the numbers get a little big or a little crazy, we can always just, list it out. 10 times 1, there's no way we can get these to add or subtract to negative 3. 5 times 2, okay, there you go. Negative 5 and positive 2. If you have 5 and negative 2, it'll give you positive 3, which wouldn't work. So we're going to use negative 5 and positive 2, so that way they add up to negative 3. So our answer will be x minus 5 times x plus 2. Now sometimes people just jump into x equals 5, x equals negative 2, but those are the solutions. Those are the x-intercepts of this quadratic, which is not what they're asking here. They're asking us to factor as the product of two binomials. So that's the answer there. Two binomials factored out. So don't just give me those answers. That would be wrong. All right, here we go. We got this area model. The idea here is they give us the length, they want the width. They give us the area and the length, they want the width. So how do we do that? Well, here's 20, here's 5. Let's just say we have some regular numbers, and you want to know what the width is. Well, you just divide. 20 divided by 5, it's 4, which is really just factoring, is division, right? Because 4 times 5 is 20. So we're trying to figure out what two things multiply to give us 20. So what I'm going to do is I'm going to take that x squared minus x minus 72. And I'm going to go ahead and run it through that typical factoring, diamond method, whatever you want to call it. What multiplies to negative 72 and adds to negative 1? We don't see a 1 there, but there is. So what multiplies to 72? Well, 72 and 1, no way I'm going to get those to add and subtract. We need them to subtract, though, because one of them's got to be negative, because it multiplies to a negative. There's no way those are going to subtract to negative 1. What about 36 and 2? That's not going to work. There's no way to get negative 1 out of that. What about 9 times 8? So sometimes it helps to just kind of go through the list of what multiplies to this number. Don't think of what adds to negative 1. There's an infinite number of numbers that add to negative 1. But there's a very finite list of numbers that multiply, or integers that multiply to 72. So 9 and 8 could work if 9 is negative. So we'll use negative 9 and 8. So, well, x plus 8 is one of ours, so that must be the length. So that means our width will be the x minus 9. So you're just going to answer with the one factor in this one.